Hello students, welcome to the Old Time Biometry Show. Today I'm going to show you how to do a comparison of slopes and then an ANCOVA, which is a comparison of the heights of two or more lines. So here's the problem. We have two species of crickets, Gryllus rubens, that's these open circles, and Gryllus texensis, which is the closed circles. And we're basically trying to compare the species in terms of their pulse rate. The problem is pulse rate also depends on temperature, and so we want to kind of factor out the temperature effect. And so it would naturally be an ANCOVA, and we would then be comparing the height of this line to the height of this line. But before we can do an ANCOVA, we have to compare the slopes of the two lines, and so that will lead us into the problem. Here I've copied the data over. We've got species, temperature, and pulse. And then you would go to Analyze, General Linear Models, Univariate. It's still univariate because we're only studying this pulse rate. That's the only dependent variable. And then species, you could say, is a fixed factor, and temperature is a covariate. And then maybe you click on model here, and I like to do everything myself. So species is a main effect, temperature is a main effect, and then species and temperature together are an interaction term. That interaction term will be the comparison of slopes. So if that's significant, then we have to do something, and if it's not significant, then we have to do something else. Click continue, okay. And here's the ANOVA table, and then you can see that the temperature by species interaction term is significant. So that means that the slopes are not homogeneous, they're heterogeneous. And normally at this point, I would recommend you then go and do separate regressions for each species. So in other words, relate pulse rate to temperature for Gryllus rubens and pulse rate to temperature separately for Gryllus texensis. Actually, I don't think we care anything about that. Everybody knows that pulse rate depends on temperature. What we really want to do is compare the species, and the problem right now is that the species are being compared at 0 degrees temperature, and that doesn't make any sense because crickets would be dead at 0 degrees temperature. So now what we want to do is try to compare them at a temperature that's more meaningful, and it turns out that these data are kind of centered around 24 degrees. And so we're going to make a new temperature, which is temperature centered at 24 degrees. Could be other temperatures, but let's just go for 24 degrees. So I'll make a new variable, so compute variable here, and I'll call it centered temperature. And that's going to equal the old temperature minus 24. That. And then now we can rerun the analysis. So we'll go to Analyze, General Linear Models, Univariate, and instead of using temperature here, we'll use centered temperature. These two together, that's an interaction term. There we go. So here's our new results. We want to, again, look at maybe this bit here, and you can see that, again, the temperature by species interaction term is exactly the same as it was before. But now we can read farther up into the table and go for this species effect. And you can see that the species effect is highly significant. So that means at 24 degrees, the species differ in their pulse results rate. Good night and good luck.